Again, this diagram is based on how we presented the parts of our proof, which is actually the way we will solve our system of linear congruences. So how can we use this proof for us to be able to find the answer to our earlier problem? So the key is for us to find or present the parts of the proof at ilagay natin siya or i-contextualize natin dun sa ating problem. Meaning to say, kailangan nating humanap ng ating mga m sub I, ng ating m, ng ating big M sub I, mga a sub I, and then find the product of big Mi, x sub I, and a sub I, tapos yung mga product na yun ay ating i-add para makuha natin yung ating unique solution, modulo M. So with that, let us proceed. So as we can see, we need to find a number x that when divided by 3 leaves a remainder of 2. When divided by 5 leaves a remainder of 3. And when divided by 7 leaves a remainder of 2. So basically, a sub 1 is equal to 2, a sub 2 is equal to 3, and a sub 3 is equal to 2. So from here, makikita naman natin ang ating m sub 1 is equal to 3, m sub 2 is equal to 5, and m sub 3 is equal to 7. So taking the product of these m sub i's, we will have m is equal to 105. Thus, we have big M1 which is equal to 35, m sub 2 is equal to 21, and m sub 3 is equal to 15. Now, we have to follow yung part naman na m sub ix is congruent to 1 modulo m. So, paano natin siya pe-present? We will have this new system of linear congruences. So, 35x sub 1 is congruent to 1 modulo 3, 21x sub 2 is congruent to 1 modulo 5, and 15x sub 3 is congruent to 1 modulo 7. So, I will leave this part to you as an exercise para mahanap yung mga values ng x sub 1, x sub 2, and x sub 3. But take note that by manual and explicit computation, we will be able to find x sub 1 is equal to 2, x sub 2 is equal to 1, and x sub 3 is equal to 1. So finding the product of m sub I, x sub I, and a sub I, makukuha natin first yung 35 times 2 times 2. Tapos yung sa m sub 2 naman, for I is equal to 2, we have 21, 1, and 3. And for I is equal to 3, makukuha natin ay 15, 1, and 2. And if we try adding these products, we will have 233. Following that, we will have a unique solution x naught is congruent to x1 modulo m. And by explicit computation again, we can see that this x sub 1 is equal to 23. Now, it's your time. It's your turn to apply what you have learned by answering these simple exercises. Don't worry, at the end of this video series, I will be flashing the answers for these problems. However, it's your task to first answer it on your own and to find the exact process of finding the value of unique solution x modulo m. Take note that as you solve this system of linear congruences, you can use the diagram that is presented in the earlier part of the video.